Welcome back. Hope you were able to grab a bite to eat, maybe a cup of coffee, and ready to start some further discussion. So to build a vibrant economy in space, it's critical that we identify products and services, improve manufacturing processes for a sustainable and scalable market. Our next panel is a two-parter. In the first session, the panel moderated by Alex MacDonald will discuss why the development of in-space production applications are important to the nation and space research. In the second session, moderated by Megan Crawford, we'll dive into the perspectives of the companies that are trailblazing in this area. So let's get us started. Dr. Alex MacDonald is the chief economist at NASA. He's previously the senior economic advisor in the Office of the Administrator and was the founding program executive of NASA's Emerging Space Office within the Office of the Chief Technologist. He is the author and editor of a number of NASA reports, including the economic development of low Earth orbit. He's a former executive staff specialist in commercial space at NASA's Jet Propulsion Laboratory and a former research faculty member at Carnegie Mellon. Let's go Tech. Alex was a Clarendon Scholar at the University of Oxford, where he obtained his doctorate on the long-run economic history of American space exploration. He was also an inaugural TED Senior Fellow and received the AIAA History Manuscript of the Year Award in 2016. Welcome, Alex.
Well, thank you, Christine, and hello to everybody. This has been an exciting day already, and we've got a really exciting panel here to talk about the future of in-space production, which is something that is really going to be important here through the rest of life of the ISS, but also into the future indefinitely as we learn to continue to live and work on platforms in space. So without further ado, I want to introduce this excellent panel here in the order in which they're going to present. Up first will be Professor Olivier Weck, who is a professor of aeronautics and astronautics at MIT. And he's had an extensive and storied research career in a variety of space mission and space architecture areas, and is a former grant recipient from the old NASA Emerging Space Office. So good to see you again, Ollie.
Hi, Alex. Thank you.
Yeah, he'll help inform us about why does this area matter for the nation and the future of the space industry. And next up will be Ken Savin. And Ken Savin is the ISS National Lab Senior Program Director of In-Space Production. And he is leading up in-space production activities for CASIS. And this somewhat new role really kind of testifies to the significance and growing role of in-space production activities within the overall ISS National Lab portfolio. And he's going to inform us about why this has become such a recent priority and what CASIS is doing to support it.
Thanks, Alex.
Good to see you. Next up, we'll then have Christian Meander, who is the Director of In-Space Manufacturing and Research for Axiom. He's also a former old NASA ISS hand. He's had 17 years at NASA, including roles as technical liaison for ISS mission integration operations, as well as chair of the ISS Research Planning and Working Group, which we've all participated in various ways as well. And now he's heading up in-space manufacturing activities for Axiom. And I'm really excited to hear about kind of how in-space production fits into Axiom's business plans going forward, and why a private space station destination company is getting involved in research here. Welcome, Christian.
Thanks, and hello, everybody.
And of course, we've also got Ryan Prouty, who is the new head of the ISS Research Organization, which in the JSC code structure is colloquially referred to as OZ, which makes her the Chief Wizard of Oz, and really heads up the whole organization that's responsible for integrating payloads onto the space station. And she has over 20 years of working with the ISS program, including in mission control as a flight controller, and has an immense set of operational and strategic knowledge that she's bringing to this area. And so she'll inform us about what the ISS and OZ are doing to support in-space production, as well as some of the new role that's been identified in the FY22 President's Budget request. So welcome, Ryan.
Thanks, Alex.
Excellent. All right. So Ollie, why is this area so important, right? Why should we care about in-space production, both for terrestrial needs, but also for in-space needs?
Great. Well, first of all, thanks for having me. So I come at in-space production from the space logistics angle. So here at MIT, starting in about 2004 or 2005, we had started to really look at space logistics as an area of not just practice, but research that includes, resupplying the International Space Station. We've now had well over 200 resupply flights to the space station over the years. We looked at lunar logistics. We looked at what it would take to establish a Martian base. And in space logistics, you have three fundamental modes. One is you send things ahead, you pre-position equipment, facilities, supplies. The other mode is carry along. You bring everything with you, like the Apollo program did. And then the third mode is basically you resupply. You send things as you need them, which is what we're also doing with the ISS now. And you realize as you go further and further from Earth, and as your ambitions get bigger in terms of how much science you can do, how big your apertures are, how long you're staying, are you staying there with humans and robots? It's a lot of stuff that has to come from Earth. All of that has to be launched, and the launch mass, because of the rocket equation, just keeps stacking up and up. And so at some point you realize, we are not going to be able to fulfill our long-term ambitions as a species unless we can manufacture in space, either with feedstock materials that we do bring from Earth, or with materials, that we harvest in space through in situ resource utilization. So that's point number one. Number two, fundamentally, in-space manufacturing is not really a new idea. We've done some pretty extensive surveys going all the way back to the 1970s. And I'm just going to read off to you some of the facilities that we've had in space already. Skylab had a materials processing facility. There was the monodispersed latex reactor, the Wake Shield facility, the optical fiber facility on ISS. Those take advantage of microgravity or ultra vacuum. Then we've had, the idea of building larger than launchable structures in space. So the Northrop Grumman beam builder, the Trusselator, Spider Fab, and then the most recent mission, the Archinaut mission, which is now known as OSAM-2. So there's a rich history of interest and experimentation in in-space manufacturing. The challenge now is to actually make it happen in a viable way that we can show that the value of in-space manufacturing exceeds the value of bringing everything from Earth, or even that we can do things better than deployables. That's the challenge. And so we've had a recent Ph.D. thesis here at MIT, Matthew Moragas, who did an excellent thesis on what targets should we actually set. How do we quantify and measure the benefits of in-space manufacturing using a rigorous, scientific and system engineering approach? There are three major case studies. One is manufacturing of spares on the space station, for example. So on-demand spares manufacturing. That's a very, very interesting idea, and we can clearly show the value there. The other is large deployable or large in-space manufactured structures like reflectors, large solar panels, where I think in-space manufacturing can achieve 2 to 3x improvements over what can be done with deployables. And then, the most forward-looking is planetary surface manufacturing, which almost is like construction, right, of structures in space on planetary surfaces. And so we are really, our understanding of what it takes to be successful is much better today than it was even 5 years ago. And there's no doubt in my mind that it's becoming a major driver for human expansion in space. Well, Alex, I hope that's useful as some opening thoughts.
Yeah, no, that's great. And that's the big vision, right? I mean, at the end of the day, we're not going to be able to, live in space in significant numbers and explore the cosmos at the level that we want to without this. However, we're starting from where we are. And let's go to Ken now to understand, okay, well, right now, what is the ISS National Lab doing to support work in this area? Let us know.
Thanks, Alex. And thank you for having me on the panel. Yeah, so all these points are great, and he's right, and that is what we're working towards. And I think from the National Lab standpoint, we are looking for things that are happening much sooner, like now. What can we do now that will enable some of the things that were talked about? And going to something that was mentioned in the past session, we have to also consider the so what aspect of this. So you're going to do some research. So what? What does it lead to? What does it mean? And for in-space production applications, you have to take it a step further, where I'm going beyond doing science for the sake of doing science, good science to understand or to learn something, but what is it going to be applied to? How is it going to play out? And there's other questions you need to ask yourself when you do that. You have to ask not only, is the science good, and will we learn something, and will it lead to some technical innovation that might be applied to production? But you have to also ask yourself, can we operationalize it in a reasonable period of time for a reasonable period with a reasonable amount of money? We have to ask ourselves, is it something that will be valued not only to the nation through, is it aligned with what our government focuses are or what have you, but will there be customers? Will investors look at it as something that's valuable and make it something they want to be a part of? So we're really looking at it from the standpoint of trying to build a business. So the ideas come in and we have to look at them. How will they play out? Who will be interested? What will be the economic impact of those in the longer run? And evaluating projects in that way. So that is the way in-space production applications is looking at things. And we can draw upon things that we know from the past, things that we know worked and have meaning to us moving forward. Results, as was mentioned around Keytruda in the past session, that was based on results that were found in the industry and through work done in protein crystallography on station that led to that result, which is an economically viable result. And the last thing I would say is you, in many cases, have to have an open mind to what manufacturing or in-space production will look like. You may not be making 1,000 widgets. You may make one thing just one time, but the intellectual property and the concepts caught up in that, wrapped up in that one time, are worth money to people on terrestrial, to people on Earth and earthbound markets. And there may also be situations where you only have to make it a few times, but you are making it for a space-based economy. So we're looking at things like that as well. But ultimately, it's more of a business focus, but using good science to achieve those goals.
Yeah, that's great, Ken. So, basically, the National Lab is pulling together all of its experience and thinking to figure out how to enable this going forward with particular business focus. So, Christian, as someone who is actually looking at this from the business lens, right? What potential do you and Axiom see in space production?
Sure. Thanks, Alex. I appreciate the opportunity to be here today. So I think what I'd like to talk to in the brief time here is kind of tie together what Ollie talked about in terms of that far out future, not so far, but far enough in terms of in-space production for exploration and for doing in-space manufacturing for space, and tie together what Ken talks about, which is, another aspect of in-space manufacturing, which is really in-space manufacturing for benefit of life on Earth. And where Axiom sees themselves is at the intersection of both of those opportunities, because at the end of the day, we're building a commercial space station that really is focused on creating opportunities to do that in-space manufacturing for terrestrial application at scale, but also enabling the proof of concept work that ultimately needs to be done to take those manufacturing applications to a grander scale for space applications in the future. And so, and they're tied together in the fact that if you don't create enough economic activity to move a lot of infrastructure into low Earth orbit, at some point, sustainability of these exploration endeavors, sustainability of these in-space manufacturing applications is potentially in danger. And so what you've got to do is really build economies around these opportunities. The great opportunity that, and I think Ryan will come in and touch on, is, the ISS is a great platform for doing all of the proof of concept work that we need to do today for these terrestrial manufacturing applications. Prove a technology works. Prove that you can pilot some manufacturing to some level on an ISS, and then move to a commercial platform where you can scale it. And so it's, as Ken kind of talked about, you have to prove the technology, but you also have to prove the business case. And where Axiom comes in is providing the next generation platform, not just to continue our coexistence in low Earth orbit, but to open the aperture to be that cornerstone of a larger infrastructure layer and to bring in all of these customers that can build this low Earth orbit economy. Now, at the end of the day, I think we'll get into, probably when we get to questions, kind of what do we think are the key applications along the way. And I think we know some today, but more importantly, what Axiom's trying to do is build a platform that ultimately allows us to transition all that discovery work from the ISS and continue to do it. So just like when you built the internet, you didn't necessarily know all the applications that we could do today, including this conversation. But the point is that those applications came online once the capability existed. And so in some ways, we're trying to do that as well. So I'll pause there because I'm more interested in kind of having a discussion with the group here, and I'll pass it off to back to you, please.
Yeah, no, thanks, Christian. That's great. So Ryan, right now we got a space station in orbit, and we're doing a lot of research on this, and clearly the ISS is going to be critical for a lot of the proofs of concept that we're talking about here, and making progress in the next few years. So tell us about how the ISS Research Office is enabling all this.
Oh, I would love to. First of all, I'm thrilled to be here, thrilled to be leading the research office. It's been many years since I've gotten to speak to this conference, and I'm more excited right now than I think I was even when I took the office, just listening to the synchronicity almost of how all of this comes together and the variety of ideas at the highest level from this panel, from in-space manufacturing for space, in-space manufacturing for us, and how it changes life on Earth, and how all of that comes together as we look at building an economy. It's fascinating, and these are the smart guys to tell you the details. But as far as my role, as Alex mentioned earlier, and for those of you who are unfamiliar, myself and my team are responsible for the integration of all the research, all the technology development on ISS, and that includes everything sponsored from NASA or other government agencies, as well as the commercial and nonprofit use of ISS as a national lab. And to that end, and Christian kind of pointed it out, at least right now, currently ISS is the only crewed orbital laboratory to leverage as a proving ground for in-space production. And my job is to figure out how to support the science and the scientists and the clients to go best leverage ISS towards that future. To date, we have funded close to $40 million for demand stimulation of this type of work, and we'd like to grow that. To that end, our FY22 budget request includes a new line specifically for what we're talking about here today on this panel, specifically for in-space production applications. So assuming that all gets approved in early fall, in collaboration with CASIS as the national lab, we'll be sending out, releasing NASA research announcements, requesting proposals and some focus areas to get started on this future you're hearing about today. And same for me. I'd like to hear some more from these experts on the panel. And so, Alex, I'll turn it back over to you for questions.
Yeah, well, thank you, Ryan, and I'm glad that you mentioned that exciting development in the FY22 PBR, President's Budget Request.
Everybody cross your fingers.
Well, that's right, and so what those of us who've been following this for a while, back when I had a lot less white in the beard, this has been something that we've been recognizing as being needed for a long time. There had been a very significant effort towards in-space production, certainly during the shuttle days, and it had been hypothesized as being something that we were wanting to do as well on the station, but we really had not been investing in it enough, frankly. And over the years, a number of us have made that case, and we've now got it to the point where that's part of the President's budget request. So this is very exciting for I think this whole community, and really looking forward to seeing the exciting new projects and the results, frankly, come down from the space station, because that's really it's really the most exciting part of it. So just briefly, and not everyone has to kind of answer these things, but give us a sense of what's different about manufacturing microgravity than manufacturing terrestrially, right? You've got different phenomena. You've got different convection phenomena. What's different? What are some of the challenges, and what are some of the potential improvements? Why is this exciting? Can someone want to take that?
I'll give it a shot, Alex. So obviously, there are definitely challenges in areas that require gravity, for manufacturing. And the good news is that even 3D printing and processes that work with powders have been shown to be possible in microgravity. But really, powder is probably not the way to go for most of these manufacturing processes, whether it's metal or plastics. Even though we've shown that it can be done and the quality of those parts, there's been some work, for example, by Dr. Tracy Prater and her team at Marshall that have clearly shown that the quality is comparable to terrestrial parts, but it doesn't really take advantage of microgravity. So I'm much more excited about techniques that use wires, for example, like wire bending, techniques that take advantage of the vacuum of space. So for example, CVD, right, chemical vapor deposition, which is something where you need to create a vacuum artificially on Earth to deposit, for example, reflective surfaces and optics. So if we can start actually exploiting the vacuum of space in a way that it's expensive to do on Earth, then we'll really, really take advantage of it, and not just view microgravity and vacuum as a nuisance, essentially. I also, if you don't mind, I just want to mention some of the applications as well of in-space manufacturing that we looked at, and we found many potential applications from structurally optimized systems, repairable systems, recycling of orbital debris as feedstock, on-demand manufacturing of spares, systems that you want to test them on orbit. You don't want to test them, if you look at James Webb, for example, if we could manufacture something like James Webb in space instead of taking 2 decades to test it in a 1G environment. And of course, the ultimate frontier, planetary surface systems.
That's great. Any other thoughts on that one?
So real quickly, I think there's 2 modes of thought. There is the mode of thought, hey, we're going to take what we do on the ground and translate it into what can be done in space. And we've perfected a lot of manufacturing techniques which can be applied in space, and that's what Ollie really had described. And and some of what I would think the National Lab is looking for in-space production will be similar. But we are also trying to capitalize on the things that are different. Access to the vacuum of space is part of it, but microgravity has really been, if you look at all the research the National Lab has gotten, it's got to be 80-90% of all the research has been focused on utilizing microgravity for the difference that it provides you. And when you do it that way, then you have to start to look and see, well, where can you really have an effect? Where does microgravity allow you to see factors that were covered up by gravity in the past, whether that be things that buoyancy or convection hid? Those are gravity dependent forces, and allow you to understand those hidden factors to a greater extent? Or do you have the opportunity to do things in space that cannot be done on Earth? So that would be looking at the ability to grow better crystals or larger crystals that would precipitate out or be made imperfect through the action of turbulence caused by convection. So it's a different mode of thinking, but ultimately that's what we're looking for. But I think the other points that were brought up are key. Understanding that the amount of mass that you're carrying up, even though there have been great strides in our ability to launch material into space, it is still very expensive. It's still going to cost you, at least in just upfront cost, about $25,000 a kilo to get stuff into space. And that means that whatever you make has to be worth at least that much to you, whether you're going to leave it in space or you're going to bring it back down. So those are the kind of the things that I look at as key factors for manufacturing in space. But once you've gotten beyond those barriers, it is wide open as to what you're going to do. And there are, I believe, really fantastic opportunities, especially as we start to reach further out into space. So not just benefits for people on Earth, but as part of the exploration effort as well.
That's great. Yeah, thanks, Ken. So we're coming up to kind of the end of the last 5 minutes here. So I'm going to kind of package one last question with a couple of elements here. The two parts of this question are, as I said, we've been talking about this for a long time, right? It's not like this is a new idea for the community. So what is different about in-space production this time around? And then second, what application are you most excited about? Choose one. Why is that the application that you're excited about?
Let's see. I think I'll take a first cut at that. What is different to me is there's a couple different things. One, it's the diversification of platforms in orbit that Axiom's beginning, and there's other players in the marketplace that want to do similar things, whether it be crewed or uncrewed variants. So there's new capabilities, new technologies that enable the destination to do manufacturing, and then the transportation schema has completely changed with both small launch capability and some of this commercial capability that's coming online all over the world. To the extent that I worry about how much market there is for all of this launch capability that is coming online, but this manufacturing capabilities, these ideas can really fill that void in the future. And so I think the ability to get things to orbit, the fact that costs are coming down because of the transportation efficiencies and the competition in the marketplace, and the fact that we're building platforms are tremendous assets. When I look to the future and what I get most excited about, we talked about manufacturing a lot of physical things in space so far, but quite honestly, some of the things that I get most excited about are manufacturing in the life science arena. When you can move life science into microgravity, you could get a lot more biologically relevant environments. And from that, you can create a lot of potentially interesting products and potentially even go down personalized or individualized medicine routes. And so for me, there's a lot of hurdles that need to be cleared in terms of getting products like that down from space. It's not inconsequential, for example, that the regulatory environment, we have to figure out how we get FDA to get comfortable with, making things in space and bringing them home and putting them into a human. But when I think about the life-saving applications that some of the manufacturing we could do in orbit, improving health on Earth, that's a pretty tremendous asset. So that's my contribution here.
That's great, thanks. Who wants to go next there, Ryan?
Yeah, Christian said it as always much better than I would have, but that is my most, I am most excited about the health applications as well. How can we deliver individualized cures, better life for people on Earth based on the value of thinking about it differently? Like Ken said, think about it upside down. What can we produce in microgravity that we cannot produce as well or as pure as we can down here on Earth? And what does that mean for life going forward? And the difference for me is being able to apply everything we've learned in the 20 plus years of long duration applied research on the space station to how we take that forward for in-space manufacturing in the future. I think there are a lot of lessons there we take forward to save us time and money in an environment where we're trying to build an economy.
That's great. Ken, any response or final thoughts?
So real quickly, I think Ryan and Christian are saying it's real. It's like it's happening now and we're seeing it. And it's not just the more launches, but it's people really seriously talking about new platforms in the future that we have in space and making this real. My opportunity is actually much more mundane. And my opportunity, I would say, is if someone would put together a very simple analytical lab that allowed people to do iterations on station where you didn't have to bring things down to figure out if they worked or not, but you did it there, you could make decisions and then run them, rinse and repeat on station. I think not only is that would that have a huge impact on our ability to make strides forward and do it at a lower cost, but it would also speed things up. And I think it's an opportunity for a business to be started. I think that would be a business that could make money and would work based on solid, fundamental science that we already understand.
That's great. Thanks, Ken. That's a great idea. Ollie,
Yep.
favorite ideas, closing thoughts?
Super quick. I think the real difference now is the emergence of additive manufacturing. If you think about it, most manufacturing processes we've had for centuries on Earth, you start with a big block of material and then you shave away whatever you don't need, right? Subtractive manufacturing. And that doesn't work for in space. The emergence of in-space additive manufacturing, whether it's 3D printing or any other technique, that is the big game changer here. That's number one. Number two, I'm most excited about these large, extra large gossamer structures. So a star shade, imagine a star shade with a diameter of 1 kilometer or even a mile, 2 kilometer star shade that you could use to detect exoplanets that are really the size of our Earth. So finding a true Earth twin with star shade a mile in diameter and finding a true twin of our home planet Earth, that gets me excited.
Yeah, I think gets us all excited. Well, thanks for giving us that kind of inspiration, vision, and thank you all for all you're doing to enable this new ecosystem. It's incredibly exciting, and I'll just say that as an economist, I mean, I don't have the same levels of thoughts on the types of applications, but I personally was really heartened to see Administrator Nelson reference the recent Senate language that came out in the bill talking about a microgravity national lab, because that kind of permanent institution for always advancing this work in potentially an FFRDC format, which is what the Senate language talks about, that could be incredibly important for advancing this area. So we're making a lot of progress now. There's a lot of new capabilities coming online, and we have a bright future for delivering value to the American people and to the commercial marketplace as a whole. So with that, Christine, back to you.
Thank you so much, panel. Alex, thank you for heading that conversation up. Amazing perspectives, and we're really excited to hear about it. But now we're going to hear from some of the people who are trying to make in-space production a reality. To attend the next session, please be sure to click the button under the panel session title in the attendance hub, and we'll see you there.